Respected Chairman of present technical session, Dr. S. Srinivasan, former Director, ICAR-CIRCOT, Mumbai. Respected Co-Chairman, Dr. R.P. Nashne, former Head of Department of one of divisions of CIRCOT, and presently Chairman of Indian Fiber Society. The rapporteur of today's function, Sri A. Arputraji, Senior Scientist, CIRCOT, Mumbai, and speakers of today's technical session, present technical session, Dr. Sachin C. Gondhalekar, Senior Scientist, Aditya Birla Science and Technology Private Limited, Panvel, Dr. Gopal Agrawal ji, Director, Riddhi Siddhi Group of Companies, Aurangabad, former and present employees of CIRCOT, members of ISKI, Indian Fiber Society, Cotton Association of India, and our beloved former director, Dr. A.J. Shaikh, CAE, Mr. Nepani. I extend warm welcome to one and all on the occasion of 99th ICAR-CIRCOT Foundation Day and Agricultural Education Day. I extend happy welcome to one and all, and also say happy foundation to one and all. On this occasion, we have organized one seminar. In this seminar, 2 technical sessions are there. One technical session is starting now. Another technical session will be a post-lunch session. There are 6 lectures, and we have tried to arrange lecture in such a manner which are relevant from the today's scenario. This session is very, very useful to 2 persons from industry. They are going to make the presentations. I hope the program will be a great success. We will enjoy the day. Once again, IP Foundation Day to one and all. Thank you. Now I hand over this chair to Dr. S. Srinivasan for next for taking up the session forward. Thank you, sir.
Thank you, Dr. Shuklaji. Formally, officially, we are going to begin this first technical session. First technical session is about value addition to cotton and its biomass. And today we have with us Dr. S. Srinivasan as a chairman and Dr. R.P. Nashne as a co-chairman. And this is a pleasure to me to briefly introduce both the chairman and co-chairman. In fact, no introduction is required, but those who are new, for them it is required because the new staff has joined now. Dr. Srinivasan, now CIRCOT has completed 19, this is 99th Foundation Day, and 98 years we have completed. And out of 98 years, for 1 decade, for 10 years, Dr. Srinivasan was a director. So this indicates that how much he has contributed to this institute. And his MSc and PhD and Fellow of Textile Institute, Manchester. And his specialization is especially fiber physics and textile physics. He was a guide of Mumbai University, research guide of Mumbai University in the field of Faculty of Physics. And number of research papers are there, number of projects are there. Everyone knows if you search for Google Scholar, you will get everything. And similarly is about Dr. Rajan Nashne, who was head of the division of quality evaluation and improvement divisions about 7 years. Both Dr. Srinivasan and Dr. Nashne, both of them, they joined the institute on 2nd September 1974. On the same day, chairman and co-chairman joined the institute. And it is a pleasure that both of them are here together as a co-chairman and chairman for this session. Dr. Nashne also MSc from IIT Mumbai, PhD, and he is also Fellow of Textile Institute, Manchester. And his specialization again, fiber physics, textile physics, and his innovation in inverse textile relation is well known in the field of fiber physics. And now I request Dr. Shuklaji to welcome both the chairman and co-chairman with floral bouquet. Dr. Nachane is. Yeah. Yes. And special introduction about Dr. Nachane. Today's function is organized by Indian Fiber Society and Indian Society for Cotton Improvement. And Dr. Nachane is currently president of Indian Fiber Society. Dr. Shekhar reminded me, and he is the secretary of Indian Society for Cotton Improvement. Uh, Now, I request Dr. Srinivasan to uh, take over this session and start this session. Thank you, sir. Yes, sir.
Morning. Happy to be here because it's a professional home. So happy to be in home. And on my behalf also, I extend a very warm welcome to all of you and a happy Foundation Day. 99 years of an institute is not a small achievement. It's a great milestone in one's institute's history. What the institute has gone through in the long 99 years that it has spent, 98 years, 99th year beginning, yes. So in 98 years, what has gone through, what the institute would have been and what it is today. Of course, I may not be a testimony for all that year, all those years, but at least 48 to 49 years or almost half of the number of years we are here, we were here and we knew what happened. So it's a illustrious career for the institute and the illustrious career for the people who contributed to make this institute what it is today. So we sincerely remember each one of them, whomever we know, whomever we have seen, whomever we have interacted. Many of them were stalwarts in their own respective fields. They did what they could have done at that point of time, contributed in every way that is possible. Many of them are not with us today. They have spent their lifetime usefully, and may their souls rest in peace. At the same time, many of them are today with us. Some may be here, some may not be here, but we do remember each one of them at this point of time and significantly, sincerely acknowledge their contribution in making the institute what it is today. With these few words, I would not talk further about it. Let the sessions begin. Let the presentations be there. Maybe a summary of it could be done at the end of the session. Thank you very much. Okay, the first lecture is by Dr. Sachin Gondhalekar, who has obtained his PhD from Textile Department of II Institute of Chemical Technology and joined Aditya Birla Science and Technology Group, a corporate R&D of Aditya Birla as scientist. Currently, he is a senior scientist responsible for providing innovative solutions to Viscose business. And he has 12 international publications in peer-reviewed reported journals to his credit and filed 2 patents in viscose production domain. Viscose production today is not the viscose production we knew when we were in these days when we were here working. I'm also aware that today natural fibers have also become a raw material for production of viscose. That means an environment-friendly production technique has been established for viscose. Whatever lacunae, whatever comments, whatever criticisms were there may have been answered, and an eco-friendly production technology might have been established. And that's the reason why eco-friendly fiber like natural fibers have been also a part of the raw material for viscose production. So it would be interesting to know a competitive cellulose fiber, how it behaves, how it performs, how it is able to contribute to the textile pool, what are its innovative features that could be accommodated as an apparel fabric. how it is competing or competing with cotton as well as contributing to textile world. So would be an interesting lecture. Let me request Dr. Sachin to present his presentation. Thank you very much.
So thank you, sir, for giving me this opportunity to present whatever advances that is currently going on in viscose industry. So sir rightly pointed out the viscose industry has changed a lot, and I have changed a lot since last 20-25 years, and I have witnessed it for the last 9-10 years. So there has been a major paradigm shift from the conventional viscose process to currently what the viscose we are operating. The major reason for being forced viscose industry to change or adopt a new sustainable practices. One is the pull from the customers, because customers are now more aware about the environmental friendly product, where viscose is basically a chemical intensive process. I'll briefly talk about it, and what are basically currently we today will mostly talk about the diversified raw materials. So what are the new raw materials that we basically are introducing in the viscose rayon production to make the process more sustainable. So to start with my presentation. Okay, to start with the Aditya Birla Group, basically Aditya Birla Group is a very diversified business and present in most of the different segments. We are number one in cement production, then largest recycler of aluminium. We have the largest single location for the copper smelter, and obviously we are the world largest viscose rayon manufacturer. We're number one in carbon black, third in insulator, fifth in acrylic fiber, and we are also into non-chemical businesses. Like we have a presence in retail business, Vodafone Idea, then the financial services. So basically we are very large conglomerate. Okay, so if we see the viscose staple fiber, basically during year FY 2009, we were around 334 kilotons per year, and we ramp up our production capacity, and now we are increased it threefold to 1,029 kilotons per year. So we are the global leader in the viscose manufacturing. And now recently, in last 10-15 years, we have a very strong focus on R&D with the very state-of-art facilities in India and other overseas units as well. So one of the key thing that I want to highlight is basically Aditya Birla Group is striving for 100% natural man-made biodegradable fibers with 360-degree sustainable goals. So we have different units started in 1954 at the Nagda unit, and then we expanded to different locations. Now we have different locations at Harihar, which is at Karnataka, 2 units at Gujarat, Vilayat and Kharach, 1 unit at MP, and 1 unit at Karnataka already talked about. In Karnataka, we have the pulp production facility as well as the fiber production facility. Along with that, we have acquired different pulp units overseas, like AV unit, then Domjo at Sweden. So this is about our total portfolio of our presence at Indian and international units. Yeah, can somebody change to next slide, please? Yeah, for those who is not quite familiar with the viscose process, I'll briefly go through the process once. So basically, viscose fiber is made from a cellulose. Viscose fiber is basically a cellulosic fiber. It is 100% cellulose. So it starts with the pulp. When I say pulp, pulp is basically wood pulp, which is, and the woods are basic, either it can be come from the hardwood or it comes from the softwood. So typical hardwood that we used in our process is eucalyptus, then maple, and the softwoods that we use is spruce, pine, etc. So eucalyptus is the the major hardwood that we use in our process. So it goes through the pulping process. There are different pulping processes like the kraft process, sulfite process, and the pulp has a very stringent parameters set for the viscose process, and therefore this is a specialty grade pulp, highly we can say highly purity wise high purity pulp, wherein the cellulose percent is typically more than 90%. Then it is first is reacted with the caustic solution. We treat it with 18% caustic solution, and we form alkali cellulose. So basically, the hydroxide groups there on the cellulose chains are substituted by reacts with NaOH to form ONA. So we call it as alkali cellulose or alkcell. Then alkali cellulose is then allowed to mature and basically for the depolymerization process. So it get depolymerized to achieve a desired DP. And in the major step of the viscose process is xanthation, where it is allowed to react with CH2 and it forms cellulose xanthate. So once why we form cellulose xanthate, because we want cellulose solution to be in the dissolved state. It should be in the polymer solution so that we can able to spin it from the spinnerets. So once the solution is formed, we dissolve it in a dilute alkali and we form a viscous solution which looks like honey. Obviously, can't compare with honey because honey is slightly more viscous, thick. It is not that thick, not that viscous. So once that is the solution is formed, then we put it into the spinneret and we draw it from the spinneret and we form the fiber. So this is the overall process. And once the fiber is formed, we cut it into the staple fibers, we wash it and we dry it, and then we send it to the customer. So this is how the viscose process basically looks like. And if you see, the major raw material is the cellulose pulp, and it is the major cost contributor in the process. So what is the requirement of cellulose? Because when I say I need to look into the alternate raw material, first I want to know which are the attributes or the characteristics which that should be possessed by the pulp. First is the product should be homogeneous, very much uniform. And why I'm focusing on this particular point, and whenever I say any natural product, it comes with the variation. It has inherent inhomogeneity attached to any natural material. So whenever, obviously, these pulps also comes from the natural material, but these pulps are processed in such a way that the uniformity is maintained, because viscose cannot tolerate a very high differences in the properties when we change from bale to bale. It has high cellulose content. Just now I told that more than 92-94% is alpha cellulose content that should be there in the pulp. Then it should be controlled. The viscosity is very much, very important parameter that we need to control, because finally I have to prepare a polymer solution. If the viscosity changes slightly also, then there is a major impact in the final product that I am making, either in the processing or in the properties of the material. And then the molecular weight distribution, not only the depolymerization, but also the molecular weight distribution plays a major role in defining the property, especially the tenacity and the elongation of the fiber. Then obviously I talked about the purity. Purity is the major attribute of the dissolving grade pulp, because it should have low hemicellulose. The hemicellulose or the permittable limit of hemicellulose is only 3 to 4%. Then high brightness, total extractive should be low, metal ion should be low, and obviously brightness should be high. That's already talked about. Yeah. Now, why there is need to change the pulp or look for the alternate pulp? One is the pulp prices are very much fluctuating, and it depends upon the viscose prices. Basically, depends upon the pulp prices. The graph at a so this graph tells about if the pulp prices increases, you can see the viscose prices also increased. So fortunately, unfortunately, the pulp prices currently are at a lower level. In 2020, during the lockdown, it was the lowest. And when there are pulp prices are higher, basically the R&D in this segment are more prominent when people look into some alternate. When the pulp price is lower, then again the interest in the R&D is also drops down. This is something happens. But yeah, we continue to do our research in how we can form a sustainable fibers. So pulp alone contributes to 50% of the total fiber production cost, and why we have a dedicated efforts into developing a new alternate raw material is because pulp prices always fluctuates. Today it is lower. That doesn't mean that it will become, the pulp will sold at a lower level. It will again rise in the future. And it is again a major sustainable goal. People are because there are customers. Finally, we are selling it to the fabric manufacturers. So there are certain requirement coming from their end as well to make it more sustainable. There are some environmental norms also which for the pulp also. So that makes us or force us to go into the sustainable fiber domain. So when I say alternate pulp, there are different sources basically we are looking into. First is the bamboo pulp, then there is jute, banana, bagasse, then there is textile waste, and there is cotton linters. So these are the four major types that basically we are exploring for the pulp production. So bamboo is something which is very much studied, and people are basically in some overseas units, people are making pulp from the bamboo fibers as well. In India, there is continuous research going on how we can use a bamboo pulp, because in India the conditions are favorable wherein we can grow the bamboo rather than the eucalyptus and other plantations. So this is the area in which we are working. Second is the other agricultural waste materials or the raw materials which do not actually have the inherent value which it should get, like jute, banana, bagasse. Again, that thing we are exploring whether we can use the waste materials or jute. In jute case, it is you can use it as such because it has very high cellulose content, and how we can leverage the production that we have in India into basically how we can get into the bring these things into the viscose domain. Then the major research all over the world is going on using the textile waste into the viscose. Textile, when I say textile waste, basically I'm talking about the cotton. Okay, because cotton is something that we can use. Cotton is a cellulose, because that is something we can use. Leaving the other things like polyester, wool, and if there is any other, we separate it from the cotton and use cotton. First bring cotton into something which can be processed at the viscose setup, and then we use it in the viscose. And fourth is the cotton linters, how we can use the cotton linters in the viscose process. So first, pass criteria for making anything work in viscose is the cellulose content. So anything which has less cellulose content can't be used in the viscose process. Just because if you take any agricultural raw material, it will definitely have some percent of cellulose, hemicellulose, the lignin, extractives, everything. But if the cellulose percent is low, basically the cost calculation or the economics does not fit, because you have to process the pulp, and if the cellulose is less, basically the yield of the material is less, and therefore most of the things are straight away neglected in the first case because the cellulose percent is low. But there are some things like bamboo I already told, and jute is something which shows very high cellulose percent. So jute is something that we are working on, and in jute also we have seen that it can be used as a potential raw material for the viscose fiber. Again, there are certain quality parameters I told you. This is the viscosity of now I'm comparing it with the wood pulp or the dissolving pulp, which generally used in the process. So typically the viscosity of the pulp is around 15 to 22 cp, wherein the viscosity of jute pulp is 18. So it is pass. Then alpha cellulose is also we require, I said 93, 94%. So again, jute pulp has very high alpha cellulose. So this is also in this, criteria also jute pulp pass. Hemicellulose is also less. So ash content is also less. The problem is with the silica, because jute pulp contain very high, concentration of silica, which is not at all, which is way beyond the tolerance limit of the viscose process. When there is silica present in the process, there is filterability issue. When I have a polymer solution, it should pass a certain filterability criteria. If there is high metal content, then it does not pass the filterability criteria, and basically the fiber which we produce is not continuous. It breaks during the spinning. So we are working on this problem also, how to reduce the silica. Again, whenever I take any raw material, it has to pass through the pulping stage, and that is also considered. And there are certain progresses that we're making in the jute fibers. So yeah, the next slide. So next important area is the textile waste recycling. And this is, very much studied and very much explored at our R&D units. And this is the commercial success that we have got in terms of the R&D and using or integrating the textile waste into the viscose fiber. So basically we have very large, a production of cotton, 26 million tons, and it is most widely used natural fiber in the textile. So basically post-industrial waste, like, during the cutting and during the initial stages like spinning, weaving operations, basically the cut pieces are thrown into the waste. And the major problem with the cotton is cotton waste and scraps are generally destined to downcycling. Basically they go into the incineration, then they are dumped into the landfill, and basically the value is degraded. So the cotton has very high cellulose component. It has, our requirement is only 93-94% cellulose. Cotton has around 98-99% cellulose. So this is the major, look or the major plus point for the cotton. And basically, therefore, the research is focused on basically, but there are certain impurities in the cotton as well. Like, dust count is very high in cotton. So these impurities needs to be separated when basically we prepare a fiber out of or any yarn out of the fiber. It has other mixes also like polyester, wool and other things. So we have to separate that colors. Then there are different fillers. So we need to separate before using it as a raw material. I told you, whenever there is, impurity of at ppm level also, it shows problem in the viscose process. So it should be free from all these things. So one way is going into the chemical recycling, wherein we separate the polyester part from the cotton part, and whatever the purest form of cotton that we get, we use it in the process. So we are trying to do that. So for chemicals, the route is going to recycling, then desizing, then basically shredding, and whatever shredded material we do it the chemical recycling or the chemical separation of the petrochemical and the cotton things. So glycolysis is one of the way which is explored, wherein the polyester part dissolves and we can filter it and separate the cotton part. So and then we do the analysis and we used it for the viscose making. So this is the typical process. So this graphs basically talks about this XRD pattern, and this shows that when there is a mixture of PT and cotton, basically this is how the XRD is formed. And we know that the cellulose is, we have a very sharp alpha cellulose peak at 21.7 theta value. So when basically we separated or recovered the cotton, we have got a very good separation of cotton, wherein we did not observe any PET peaks in the recovered cotton. And basically we use this cotton in our viscose. Again, the catch is that we cannot use it 100% because I told there are certain impurities which are in the ppm level. The major thing that we have observed that even after the separation, there are some, ppm level polyester remains in the pulp, and that causes a very, the filterability issue. And there is another coagulation of the polymer solution that is being formed. So that is also observed in most of the cases. So we are working out how to remove that part and provided 100% discard, 100% cotton pulp to us. So we tried, did different experiments, and we find out the perfect combination wherein we can use 20% of the circulose fiber, that is the recycled cotton fiber, into our viscose system. And it has, at R&D level, it has shown fantastic results that it can be 20% of the this pulp, recycled cotton pulp, can be introduced into viscose system without affecting the property. Obviously, we need to fine tune the process parameter in such a way that it can accommodate the cotton fibers. And finally, we can able to do it at a larger scale, at scale up facility, which is at Gujarat. There also the trial passed successfully, and now at commercial level, we are producing the viscose fibers with 20% of the recycled cotton.
Dr. Sachin, can I request you to have 5 more minutes?
Yes, sir. Thank you.
Thank you. Thank you.
Yeah. So we are basically introduced a new brand known as Reviva, wherein we blend 20% of the consumer waste, this cotton waste, and 80% of our regular dissolving grade wood pulp. So this is currently marketed under the brand name Reviva, and it is sold out for the premium customers. Yeah, next slide. Yeah, and the next major, the interest is using the cotton linters in the viscose process. Again, why basically the interest focus towards the using cotton linters? First is very high cellulose content compared to softwood. Softwood content around 93-94%, wherein our cotton linters contain more than 98%. Then it is known to improve the tensile strength, especially the weight strength of the fiber. And it has lower polydispersity index. I'll talk about it in the next slide. And it has less pre-treatment compared to dissolving grade pulp, because in dissolving grade we have very high concentration of hemicellulose and lignin. In cotton we do not have that much. But a disadvantage is higher crystallinity. Generally, our dissolving grade pulp have lower crystallinity because of the pulping process, the harsh treatment of sulfite and caustic. Then it has very high molecular weight, very high dust count, low luster, and low reactivity towards NaOH and CH2. So which basically limits the use of cotton into the viscose process. So cotton has a very simple pulping process, unlike the other processes. Cotton chemical pulping process, it uses less chemicals. It uses less stringent conditions for processing. So if we see the comparison of dissolving grade pulp with the cotton linters, cotton linters have very high alpha cellulose content. It has low DCM extract, ash, moisture, everything is less. The only problem is with the DP. DP is very high in cotton compared to the other dissolving grade wood pulp. And this is the major challenge that we face. And because of the high DP and high crystallinity, it limits the reactivity of cotton pulp to the NaOH, which is the first treatment that we give to the pulp, and subsequently in the xanthation process. The good point is cotton has very narrow polydispersity index, and this is something which is we always go for the pulp which has very narrow molecular weight distribution. So even after, if you see the first graph, that even after the alkali treatment, the crystallinity of the cotton does not drop significantly to a level it should drop for the wood pulp, and this is a challenge. And another thing is the degree of polymerization. This is good thing. The degree, if you have the higher degree of polymerization, basically we have the higher tensile strength. So there is a direct relationship. But again, when we have a higher degree of depolymerization, basically we have to mature it more. We have to bring it down in order to have desired viscosity of the viscose. And this is how it treated with the XRD shows how it treated an untreated cotton linter basically looks like. So it has all the property which is needed for the viscose processing. The only part is that we are working on removing the dust from the cotton. That is the one thing, because that is affecting the filterability. And other thing is the basically how we can reduce the crystallinity and reduce the depolymerization. And we are currently working on, and we are getting some good results with a 10% blend. And we are trying to increase it so that we can at least reach up to 20% level to have some commercial trials. So basically, recycling is something that is in, and that is all are trying to work. And the major teams at R&D centers are working dedicatedly towards use of alternate raw materials. So reduction of raw material is important because it reduces the overall cost. Because when I see any commercial process, the first thing that comes into the mind of the senior leadership is the cost of the material that is finally forming. But not only the cost, it is important regulatory mandate from the government as well to use the sustainability product and to move toward the sustainability. And it is also seen that not only the cost and sustainability are true parameters, but it also shows the improvement in the property. Like in case of cotton, it improves the tensile strength of the fiber, and this is requirement of many customers. So again, on the environment front and society front, basically it can bring the large volumes of waste into the system. It increases again the H&M, Kering, the IKEA, the branded customers basically demand for apparel which are manufactured from the recycled route or recycled cotton route. And it attracts full government support as well whenever we go for the recycled material, the sustainability, and it is going to be the major market drive in the future. So this from my side. Thank you.
Thank you, Dr. Sachin,
Thank
for
you.
keeping to the time.
Yeah.
And thank you very much. Now we shall discuss together after the second presentation is also over.
Sure.
Thank
Sir.
you for your time.
Thank you.
Thank you. The next presentation is by Mr. Gopal Agrawal. He has experience of more than 23 years in cotton trade, manufacturing and marketing of cotton and allied products. He's on the board of Cotton Association of India for the past 5 years. He's a visionary leader and decision maker in the group, and is strongly supported by his brothers. The group's major activity includes cotton ginning, processing and spinning. Group owns 4 ginning and pressing units and 5 spinning units in different states in Maharashtra, Telangana, Tamil Nadu, Kerala, and Karnataka. And future plans for expansion is also there. I would request Mr. Agrawal to make his presentation on cotton. Thank you.
Respected chairman and co-chairman sir and friends, hello, good morning. I feel very honorable कि आज मुझे सिरकाट के 99th फाउंडेशंस डे सेलिब्रेशन के लिए इनवाइट किया है। इससे मुझे बहुत खुशी हो रही है। कॉटन जैसा कि हम सभी जानते हैं कि संपूर्ण भारत के लिए एक कैश क्रॉप, किसानों के लिए कैश क्रॉप है, और इंडिया के डायरेक्ट और इनडायरेक्ट काफ़ी पॉपुलेशंस इस बिजनेस से जुड़ी हुई है और मेजर एम्प्लॉयमेंट सेक्टर है। इंडिया की जीडीपी में टेक्सटाइल्स का करीबन 7% शेयर्स है और एक्सपोर्ट के अंदर 11% टेक्सटाइल्स और अपीलियर्स सेक्टर का है, इसलिए इसे एक वाइट गोल्ड भी कहा गया है। गत वर्ष इंडिया में करीबन 1,30,00,000 हेक्टेयर्स के अंदर कॉटन सोइंग हुई थी, 1,20,00,000 हेक्टेयर में कॉटन सोइंग हुई थी, और दिस ईयर अप्रॉक्सीमेटली 1,27,00,000 हेक्टेयर के अंदर कॉटन सोइंग हुई है। आप देखेंगे कि गत वर्ष से इंडिया की कॉटन सोइंग करीबन 1,15,00,000 से लेके 1,35,00,000 हेक्टेयर तक कॉटन सोइंग हो रही है, और हमारी क्रॉप्स जो है 3,50,00,000 से 3,75,80,00,000 पर बेल्स की ही हो पा रही है। सो हम आज भी यील्ड हमारा इंडिया का बहुत कम है। मेजर 7 प्रोड्यूसिंग कॉटन कंट्रीज है, उसके अंदर इंडिया का सबसे बड़ा एरिया होने के बाद में सबसे कम प्रोडक्शन यील्ड के कारण से हमारा कम होता है, जबकि हम प्रोडक्शंस के अंदर नंबर ऑफ बेल्स के अंदर चाइना के बाद 2nd नंबर पर है। इसके लास्ट ईयर तो हमारा क्रॉप करीबन 3 करोड़ पर बेल का ही हुआ। उसका कारण ये था कि सितंबर अक्टूबर मंथ के अंदर जो बारिश हुई थी, उस कारण से जो क्रॉप हमारा ट्रेड जो पहले 3,60,00,000 पर बेल के हिसाब से एक्सेप्ट कर रहा था, जो कि घट करके 3 करोड़ पर बेल ही हो गया। और इसके कारण से हमें लास्ट ईयर हमारे जो टेक्सटाइल सेक्टर है उसे काफ़ी लॉस का सामना करना पड़ा, क्योंकि इसके पहले एक टेक्सटाइल्स का एक गोल्डन पीरियड आकर के गया, जो आफ्टर पोस्ट कोविड जिसे हम बोलेंगे कि लास्ट 10-15 सालों के अंदर ऐसा पीरियड नहीं रहा। उसका रीजन ये था कि हमारी कॉटन कॉर्पोरेशन ऑफ इंडिया के पास करीबन 2 करोड़ बेल्स का स्टॉक हो गया था, जो कि उन्होंने बहुत सही टाइम पर और ठीक तरीके से उसको सेल किया। इस कारण से हमारी कॉटन वर्ल्ड में सबसे चीपेस्ट होने से हमारा कॉटन एक्सपोर्ट, कॉटन यार्न एक्सपोर्ट प्लस डोमेस्टिक डिमांड, इस कारण से एक गोल्डन पीरियड्स पूरे सेक्टर के लिए गया। बट जैसे कि लास्ट ईयर मैंने बताया कि बारिश काफ़ी ज़्यादा होने से हमारी क्रॉप 3 करोड़ बेल की हुई, जबकि हमारा कंजम्पशन अप्रॉक्सीमेटली 3,60,00,000 बेल्स का है। और इम्पोर्ट ड्यूटी गवर्नमेंट्स ने स्टार्टिंग के अंदर लगा दी थी, जो कि हम टाइमली इंपोर्ट नहीं कर पाए। तो आफ्टर अप्रैल जो टेक्सटाइल्स है वो इतने लॉस का सामना करना पड़ा, क्योंकि हमारी कॉटन सीजन स्टार्टिंग में 60,000 रुपये पर कैंडी थी, जो कि बढ़ करके अप्रॉक्सिमली 1,10,000 रुपये पर कैंडी हो गया, और हमारी कॉटन वर्ल्ड में सबसे महंगी हो गई। जो कॉटन हम 60,000 रुपये के अंदर एक्सपोर्ट कर पा रहे थे, और उस समय हमारी न्यूयॉर्क वायदे से हमारी कॉटन करीबन 10 सेंट्स डाउन थी, जो कि बढ़ करके हम 45 सेंट्स अप हो गए। तो जो हम कॉटन एक्सपोर्ट करने के बजाय इंपोर्ट करनी पड़ी, और अप्रैल महीने में जब गवर्नमेंट ने इंपोर्ट ड्यूटी हटाई, तो उस तरफ तब इतना कम अवेलेबल कॉटन था वर्ल्ड मार्केट में कि हम टाइमली इंपोर्ट नहीं कर पाए। सो ये हिस्टोरिकल फर्स्ट टाइम इंडियन टेक्सटाइल्स करीबन 50% से 70% कैपेसिटी में चली, और उस कारण से एक तरीके से टेक्सटाइल्स, अपरेल्स, गारमेंट्स पूरा सेक्टर जो डिस्टर्ब हो गया, और वो आज तक नहीं उभर पाया है। और वापस से अभी हमारी कॉटन अभी तक की सिचुएशन है कि बहुत अच्छी दिख रही है, करीबन 3,50,00,000 से 3,70,00,000 के हम क्रॉप एक्सेप्ट कर रहे हैं। परंतु किसान ने लास्ट ईयर जिस हिसाब से मैंने बताया कि 60,000 से 1,00,000 रुपये 1,10,000 रुपये खंडी तक मार्केट गया, तो जो किसान को 12,000 13,000 रुपये पर क्विंटल के रेट मिले थे, जो कि अभी घट करके 8,000 से 9,000 रुपये पर क्विंटल हो गए। तो किसान आज कम भाव में उसकी क्रॉप सेल करने के लिए रेडी नहीं है, और एक्सपोर्ट नहीं होने के कारण से, गारमेंट्स में डिमांड नहीं होने से, यान में डिमांड नहीं होने से, कॉटन एक्सपोर्ट के अंदर हमारी कॉटन महंगी होने से ना हम एक्सपोर्ट कर पा रहे हैं, और ना इधर किसान कम में बेच रहा है, जिससे आज 2 महीने नई अराइवल होने के बावजूद भी हमारी टेक्सटाइल 50 से 70% कैपेसिटी में चल रही है, जो कि बहुत सोचनीय और गंभीर विषय है। इससे आज रोजगार के अंदर बहुत प्रॉब्लम्स हो रहा है, बहुत फैक्ट्रीज बंद पड़ी हुई है, बैंकर्स के अंदर उनकी फैक्ट्रीज की इंस्टॉलमेंट नहीं जा पा रही है, जो कि अभी आने वाले कुछ समय के अंदर भी सुधरने की चांसेस नहीं दिख रहे हैं, अगर किसान ने अपना माल इस रेट के अंदर बेचने के लिए रेडी नहीं हुआ तो। अभी जैसे बताया कि टेक्सटाइल्स के अंदर जिस हिसाब से इतनी अपॉर्चुनिटीज होने के लिए भी हमारे बहुत कुछ सुधार या समझने की जरूरत है। हम सेकंड नंबर प्रोड्यूसर होने के बारे में भी हम उतना बेटर नहीं कर पा रहे हैं जितना कि हम कर सकते हैं। हमारी नेबर कंट्रीज और कॉम्पिटिटिव कंट्रीज हमसे ज़्यादा बेटर कर रही है। एग्जाम्पल के लिए बांग्लादेश, जहाँ की उनकी खुद की एक बेल भी नहीं प्रोडक्शन होती है, वो वर्ल्ड में सबसे लीडिंग में आज गारमेंट एक्सपोर्ट और अप्रैल में एक्सपोर्ट कर पा रहा है। क्यों? क्योंकि वो प्राइवेट तरीके से उन्होंने एक अलग सोर्सेज बना रखे हैं। वो टाइमली कॉटन कैसे परचेस करना, कब इंपोर्ट करना, कब उसको हेज करना, ये उसे ठीक से पता है। आज हमारे यहाँ आज भी हम लोग पुरानी जो टेक्सटाइल्स के बड़े प्लेयर्स है या जीनर्स हैं, वो आज भी पुरानी टेंडेंसी से बिजनेस कर रहे हैं। वो उन्हें हेजिंग क्या होती है, उसे कब माल परचेस करना चाहिए, कब सेल करना चाहिए, वो ना देखते पूरा एक्सप्लोरेटरी करते हैं, पूरे तेजी मंदी खुद की रिस्क पे करते हैं। समटाइम उन्हें बहुत अच्छा प्रॉफिट भी होता है, बट मोस्टली वो अभी लास्ट में जा रहे हैं। तो ये सब सुधार की अभी जरूरत है। हमें अपने आप को अपग्रेड करना होगा कि कैसे हम अपने आप को सिक्योर करें, आगे की प्लानिंग कैसे करें। जैसे लास्ट ईयर अगर स्पिनिंग मिल जब माल 60,000 70,000 था, तब हमारा 30 से 35 लाख गांठ एक्सपोर्ट हो गया। अगर वही एक्सपोर्ट हमारे अगर उस समय मिले यहाँ इंडियन मिले खरीद लेती, तो हमें 1 लाख रुपए की कॉटन इंपोर्ट करने की जरूरत नहीं होती। बट हमने वो 60-70 हज़ार का माल हमारे एक्सपोर्ट हो गया और 1 लाख के अंदर इंपोर्ट लाया। उसकी आज तक साइकिल पूरी डिस्टर्ब हुई है, जिसे इसे सुधारने में काफ़ी टाइम लगेगा। उसके बावजूद मैं ये कहना चाहूँगा कि हमारे किसान की भी ओवरऑल जो प्रोडक्शन ऑफ कास्ट है वो बढ़ गई है। लाइक शीट रेट बढ़ गए, पेस्टिसाइड बढ़ गया है, आपके पिकिंग कास्ट बढ़ गई, फर्टिलाइजर्स बढ़ गया है। तो इसके लिए एक ही सॉल्यूशन है कि मार्केट को एमएसपी बढ़ाना या फिर उसके रेट ऊंचे देना। वो उसके बावजूद हमारा यील्ड सुधारना पड़ेगा। आज जैसे बताया हमारा यील्ड बहुत कम है, तो यील्ड अगर सुधरेगा तो ऑलरेडी किसान को कास्टिंग कम आएगी और उसको प्रॉफिट भी होगा, और मार्केट के अंदर हम वर्ल्ड मार्केट अंदर कॉम्पीट कर पाएंगे कि हमारी कॉटन में रीजनेबल रेट में हुई। तो जिस हिसाब से हमारी स्पिनिंग कैपेसिटी बढ़ रही है, हमारे क्रॉप आने वाले वर्षों में मिनिमम 4 करोड़ से 4.25 करोड़ बेल्स की हमें नीड होगी। और आज हम 340, 350, 360 से ऊपर नहीं जा पा रहे, क्योंकि 25 से 30 लाख गांठ एक्सपोर्ट तो ऑलवेज हमारी यहाँ से बांग्लादेश होती है, क्योंकि नेबर कंट्री है, बीसीआई है, ऑर्गेनिक्स है, और शॉर्ट पीरियड के अंदर उनको माल मिल जाता है। तो इसलिए 25 से 30 लाख एक्सपोर्ट होगी। और हमारी अगर फुल कैपेसिटी में स्पेंडल चले, न्यू स्पेंडल्स बढ़ रहे हैं, तो 3 करोड़ 75-80 लाख बेल्स हमारी खुद की रिक्वायरमेंट होगी। तो इस हिसाब से हमें आने वाले टाइम के अंदर कॉटन की जो क्वांटिटीज है, यील्ड बढ़ा करके ही हम उसे वो कर सकते हैं, क्योंकि एरिया तो जितना मैक्सिमम होना चाहिए था हमने ऑलरेडी उसको कवर कर लिया है। इसके अलावा हमारी जिनिंग सेक्टर जो है वो भी आज काफी प्रॉब्लम में है। जिनिंग में क्या हुआ है कि जिस हिसाब से आज कॉटन में डिमांड नहीं है, कॉटन शीट्स के अंदर ऑयल के प्राइसेस वो काफी डाउन हो गए। जो कॉटन केक है उसके सब्स्टिट्यूट के रेट्स कम होने से कॉटन केक के रेट कम है और किसान कम भाव में माल नहीं बेच रहा है। तो ना तो जिनिंग इंडस्ट्री ठीक टाइम से कपास ले पा रही है और न वो उसका माल सेल कर पा रही है। और हमारे जिनिंग कैपेसिटी जितनी हमारी क्रॉप है उससे 2 टाइम जिनिंग कैपेसिटी हो गई, तो आपस में कंपटीशन बहुत ज्यादा है। तो ये सब कारण से हमारी जिनिंग जो आज है वो भी बहुत ज्यादा प्रॉब्लम के अंदर है। अगर हमें ये सब ठीक करने के लिए हमें बहुत कुछ सोच करने की जरूरत है। हमें करंटली अभी तो आप देखें तो ऑन गोइंग जो रिसेक्शन फियर है, महंगाई है ग्लोबली, एनर्जी क्राइसिस इन यूरोप, डॉलर्स प्रॉब्लम इन बांग्लादेश और चाइना पाकिस्तान के अंदर फ्लड्स की प्रॉब्लम, तो इस हिसाब से थोड़ा सा बिजनेस डिस्टर्ब है। बट जैसे चाइना +1 का अभी जो चल रहा है और जिस हिसाब से हमारी कॉटन खुद के पास वर्ल्ड बेस्ट क्वालिटी कॉटन अवेलेबल है, स्पिनिंग कैपेसिटी है, मैन्युफैक्चरिंग कैपेसिटी है, तो हम आने वाले टाइम के अंदर बहुत कुछ इसके अंदर कर सकते हैं। इसके लिए अगर गवर्नमेंट की फ्रेंडली पॉलिसीज बने, साथ ही न्यू वेराइटी सीड्स हम डेवलप करें और जिसके कारण से यील्ड बढ़े, हाई डेंसिटी प्लांटिंग करें और मशीन पिकिंग करके कास्ट ऑफ जो पिकिंग कास्ट है, क्योंकि आज किसान को सबसे ज्यादा कास्ट पिकिंग के अंदर ही लगता है, करीबन 1500 से 2000 रुपये पर क्विंटल सिर्फ पिकिंग कास्ट जाता है। तो वो अगर हम ये सब करने से एक तो क्वालिटी होगी, कंटामिनेशन कम होगा और प्लस में जो हमारे जिनिंग इंडस्ट्रीज है, टेक्सटाइल इंडस्ट्रीज है, इसको हेजिंग करना सीखना होगा कि उसको कैसे अपने आप को इंश्योर करे। आज हम अपने खुद का इंश्योरेंस करते हैं, फैक्ट्री का इंश्योरेंस करते हैं, बट हमारी कैपिटल का इंश्योरेंस नहीं करते। हम सिर्फ तेजी मंदी के अंदर पूरी रिस्क लेकर के उसको काम करते हैं, जिससे हमें काफी टाइम लॉस का सामना पड़ना पड़ता है। हमारे इन सब कारण से जो हम बहुत कुछ अच्छा कर सकते हैं बट थोड़ा से पीछे हैं, बट आई होप हम आने वाले टाइम के अंदर बेस्ट करेंगे और इसके लिए पूरा जो टेक्सटाइल चेन है उसको आगे बढ़ के काम करना पड़ेगा। अंत में मैं सिर्फ इतना ही कहना चाहूंगा कि जब भी तन पर लिबास होता है, जब भी तन पर लिबास होता है, सभ्यता का विकास होता है। लाग बदल ले रंग मगर, लाग दुनिया बदल ले रंग मगर, हर लिबास पर कपास होता है। सर उठाकर चौड़ा सीना कर कर चलो मित्रों, क्योंकि तिरंगे में भी धागा, रुई और कपास होता है। जय हिंद, जय महाराष्ट्र।
Thank you, Agrawal, for bringing a national fervor to the whole lecture. Thank you very much for that. The current scenario of cotton is being explained very well by you. Now we shall take some questions because we have time up to 11 o'clock, I am told. One more presentation is there? Okay, good. But you didn't tell me.
Sir,
But I am
actually,
yeah, sure.
Dr. Sujata Saxena, she was supposed to be present
Okay.
here
Yeah.
for her presentation, but due to her health problem,
Okay.
she's not coming.
Now,
So
who-
on her
you-
behalf of Dr.
Her coach
Vignesh,
will be
I am
doing.
presenting her presentation.
Unfortunately, I don't have the biodata of Arputraj with me, but he's a senior scientist, very well known in CIRCOT circles. And for his, background as a lecturer in a college, and the vast experience he carries, that college experience of teaching, living with students and interacting with them and gaining a modern knowledge to the whole business. And that he has brought to CIRCOT. And here also has been relentlessly doing work on finishing of cotton and cotton blended textiles. Has a very good experience and a very good number of publications, a well-known scientist at CIRCOT. It's my pleasure to introduce him to you and to ask him to deliver the disc. Thank you. You don't want this? Yes.
No.
Yeah, because you can't see properly. Yeah, you can probably close that. Yeah, this will be better. Yes.
Respected chair and co-chair, respected dignitaries. Yes, sir. Sure, sir. On the dais and off the dais, a very good morning and wish a very happy Foundation Day. So this particular presentation on status and issues in energy generation using biomass pellets to be presented by my head of the department, Dr. Sujata Saxena. Since he is not keeping well, I'll be presenting. I hope I can justify it. Next slide. So here you can see that the global primary energy supply sources, because now you can see that there are a lot of energy crises in the world. So here you can see that 80% of total primary energy supply from for imports, exports, and different things satisfied by the coal and crude oil and natural gas. And renewable energy technologies such as solar energy, wind energy, and biomass and geothermal energy is having a share of 14%. So this you can see that coal is a very important source, primary energy source globally. Next. So here I have given how these energy is used by the different sectors. Per capita consumption is given. You can see that India is first. It does not mean that our consumption is very less, but due to our populations, we have very less per capita consumption. But when we compare other countries like USA and Canada, which are in higher side because their per capita consumption is very high, there are a lot of reasons which influence the energy consumption in different countries. Major parameters is the industrialization and transport, because in USA and all you have to move from different places, so they are spending huge amount of energy. So different countries have different kind of energy consumption pattern. Next. Next slide, please. Yes, I think it's okay. Fine. So here you can give that power sector of our country. India needs nearly 1,500 billion units of power per year. So in 2009-10, it was a fiscal year, it's a financial year. It was 800, but in the now currently we need of nearly 1,500 billion units of the power. So this power requirement is increases in the 7% annually. So here I could see that our how we are managing our power. Actually, India, no, we use 50% fossil fuels, while globally it needs some nearly 80%. India use only 50% of fossil fuels, and we are using 50% of some non-conventional energies like hydropower and wind energy. And here you can see that this biomass power, which contributes 2.5%. We are using biomass based energy in India. Currently, we are producing 2.5% in the whole energy consumption. So what energy from the biomass, because now our government is also much interested how we can use the biomass for energy productions, because it's a renewable energy and it is widely available and it is a carbon neutral material. So it is very useful when you use a biomass for the energy production. But what is going currently in India availability, we have 750 million metric tons per year. This is by the Ministry of New and Renewable Energy. So biomass availability about 230 million metric ton is available. So by using this agriculture residue, we can produce nearly 28 gigawatt power. So we have the strength of 28 gigawatt power we can produce by using the biomass. So we have different kind of biomasses available. Here you can see that paddy is a very important agro residue in India. Next to paddy, cotton is a very important residue. Cotton stalks is a next to paddy. We have a highest amount of agro residues from cotton stalks. But what is happening? This is I need not explain this slide, because day-to-day newspapers you can read a lot of articles about what is happening in Delhi and NCR. So people are burning these, especially in this winter season. So it causes a lot of pollutions, and the government is taking a lot of initiatives how to avoid this. So this stubble banning is not a much concern in South India, because it is a major concern in northern states, especially Punjab, Rajasthan, and Haryana states. So we can produce biomass energy by using two kinds of methods. One is combustions, another one is cogenerations. So cogeneration technology is mostly used in sugar industries, where we are producing both heat and electricity. So this biomass energy potential and chemical composition, you can see that we can use very well this paddy straw, wheat straw and soybean stalks, which are having very high heating values. You see the cotton stalks, which has a heating value of 16.7 million joules per kg. And also here in side by side, I have given what is the chemical compositions. So chemical composition means what are the fuel materials? So fuel materials for biomass is a cellulose content. If cellulose content is more, we will get a very good energy we can get it. But what is the major issue? We have the major issue of the ash content. Ash content is a major issue in that biomass energy production, because it creates a lot of problems like clinker formation, sintering, and also these alkali and alkaline metals, especially sodium, potassium, magnesium. No, they're creating lot of issues when we are using in the energy production. And this particular table shows what are the different elements, minerals, which are present in the paddy straw and cotton stalks and soybean stalks. So comparatively, paddy straw, cotton stalk is a better raw material, but the issue is with the paddy straw. So the government is interested how to reduce this paddy straw banning by mixing with the other biomass materials. So there are a lot of issues with the usage of biomass for the energy production. First one is biomass has highest mineral content, which is not useful to produce the energy. What kind of solution we can have? We can blend with the biomass which are having lower mineral content. For example, this paddy straw has a higher amount of silica. So instead of using only this paddy straw, we can blend with the other biomasses like our cotton stalks, otherwise this soybean stalks or this groundnut shell, so bamboo waste. So we can blend these materials, thereby we can produce our biomass materials. And another one is low energy density and bulk volumes. So how to handle these biomass material? So first we have to do the chipping, and which will enhance the biomass energy, and also we can easily transport it. And third one is how to store it, because biomass material is known for their biodegradability. So how to reduce the biodegradability of this biomass? There is a very good solution is that it is to be converted into a pellet form with very low moisture content. Thereby it can store for the longer time. So if we make this a biomass pellet, we have a lot of advantages. It requires less maintenance and create less problems. And also we can easily transport it, and this processing cost also can be reduced. And also this energy density is increased once you convert biomass into a pellet form. Okay, so what are the requirements of this biomass to be converted into a pellets? So it should have less chloride content, and also it should have very less dust. And also we have to use some kind of binders to convert this biomass into a pellet form. So currently, what is the issue? Our country wanted to use to replace 5% of biomass by the coal. Actually, we are using 100% coal. It is 5% of this coal is to be replaced by our biomass based materials. But what is the issue? Because these materials are not having very good energy levels. So government is coming with a lot of technology. One of the technologies government is thinking is torrefactions. Torrefaction is found to be a very good solutions to deal with the issue of the biomass based energy solutions. So torrefaction is a process. It's a very simple process. The process is we have different temperatures, carbonizations and pyrolysis. It is a mild pyrolysis. Just we are heating the material between 200 to 300 degrees Celsius for 30 minutes to 1 hour. So what will happen? We will get the material of very good energy, high energy density, and also lot of properties will be improved, especially that volatile content will be reduced. That is a very good advantage of how to use this biomass material into energy. Government is also supporting to use the torrefied pellets instead of using the normal pellets. So, but there is a lot of research is required to use this kind of torrefaction technology. So here I have given how these different materials behaves when you raise the temperatures like hemicellulose and cellulose and lignin. And there are different kind of torrefaction is available currently, dry torrefaction, wet torrefaction, and steam torrefaction. However, this dry torrefaction is mostly attempted. So what is happening when these torrefy the raw material, its property will look, we can get the property like a similar to the coal. So we can easily use this kind of biomass material for the energy to be used in the power plants. So if you are using normal pellets, there is no issue if you are using in a stoves or something. But the pellets to be used in the power plants, some qualities are required, especially moisture content. Moisture cannot have more than 10%. You cannot do that. And also this ash content. So that's why government is telling use only 50% paddy straw and use any other biomass, you make the pellets. So government is coming with a lot of policy which is available in our Ministry of Power website. So we have also done, our institute is working on torrefaction of biomass materials, and we are using different biomass like rice straw and this groundnut shell, and we are doing different temperatures. So initially we are getting some success how to optimize this torrefaction process. Here you can see that. So this control paddy straw, this initial GCV value is 3270. When you do the torrefy at different temperatures like 250 degrees Celsius, it goes to 3782, and 300 degrees Celsius, it is nearly 4200. So this GCV value is increased into nearly 20-30% when you do the torrefaction of these pellets. So, but why we have this much biomass, but what are the issues? Why it is not taken up, even though government is giving lot of subsidy to the this kind of usage of biomass? Because there are a lot of issues like feedstock availability, and it is a regional based. Suppose paddy straw is available in Punjab, cotton stock is available in Maharashtra, but if you are proposing this paddy straw based and cotton stock mixing, how this material will be available? That is a major question. And farmers, they should be encouraged to use this kind of biomass material. There is a lack of awareness in our country.
Arput,
Yes, sir.
you have only 2 or 3 minutes.
Yes, sir. I have finished. So government is having national mission on biomass. We are working on these projects. So it has a objective to co-fire this 5% of biomass with the coal. And till today, that is in January, up to nearly 60,000 ton of biomass pellets have been already co-fired, and the government is coming with some kind of initiatives. They are giving different subsidies to start the pellet making plants. So if you are making normal pellet making, there is a subsidy. If you are making torrefied pellet, there is a subsidy. And so lot of things are available in Ministry of Power and Renewable Sources website. Other sources, you can get a lot of information. And CIRCOT is working to use cotton and other biomasses to get this kind of pellets. And also, as per this our government policy, this in 2030, nearly 6% of our country energy can be managed only by using the agro-based biomass. Here I am telling biomass, which is not bagasse. Bagasse is not considered as a normal biomass. Other than bagasse, we can produce energy, we can meet our energy requirement only by using other biomasses. So I thank this opportunity. Thank you for your kind patient listening. Thank you very much.
I would request Dr. Nathani to sum up whatever he wants to say in a very short time.
Thank you, Dr. Srinivasan. All the 3 presentations were very good, very informative. The first presentation by Dr. Sachin Gondhalekar, he gave us information about the production technology involved in viscose from cellulose-based materials. Of course, main problem with the viscose usage is ultimately pollution, which is created because of the viscose production. And there have been attempts to reduce the pollution level, but it cannot be completely removed. I hope from your side also you are trying to do that. Of course, that part was not covered over here, but hope it will be, it is there.
So, sir, you are rightly pointed out pollution front, because there is the major pollutants that we use in our process is caustic, then H2SO4 and CH2 and H2S gases, which are liberated in the process. And previously we used to let the gases go in the stack, but now the environmental regulations are so stringent that we almost consume all the gas. Basically recycle all the gases, and we capture all the gases. And now if you see the emission level, it is fantastic. I mean, we can capture more than 80% of the gases which are produced in the process.
Yeah, anyway, thank you. Yeah, thank you. अग्रवाल जी ने भी अच्छे से बताया कि what is the total problems in the cotton production and what exactly is required by the industry. As we all know, for the last more than 10 to 15 years, our yields have remained same. There has not been no change in the yield level, even after BT cotton was introduced. And unless there is something done about the high yield, increase in yield, we won't be able to have the production, what is required by the market in India as well as outside. Let us hope our scientists in the agronomy field, will be able to do something in the future and increase the yield. And Dr. Arputraj has given presentation on behalf of Sujata Saxena. Though it was her presentation, but the way he has presented it, seems he also knows the subject quite well. He has gone through it. And anyway, I don't want to speak much about it. We all have been very happy to get quite some information on all these three topics. Thank you very much.
No, I myself said that a lot of time will be available in tea and other places, so we will discuss a lot. Only one point I want to bring out here is that this session is very unique because, there were three presentations and all the three involved cotton in some way or other. Cotton was used in viscose in the form of linters. Cotton was used in the energy in the form of cotton stalks. And cotton itself was discussed. So cotton, cotton stock, cotton linters, so every part of cotton, every possibility of cotton is discussed in this session. And it was very interesting. Thank you very much for your cooperation. Thank you.
Thank you, sir. So before concluding this first technical session, I request our director, Dr. Shuklaji, to just felicitate both chairman and co-chairman with a memento. Dr. Srinivasan, and felicitation of Dr. R.P. Nashane. Thank you, sir. Now our three speakers are there. First, I would like to felicitate, request Dr. Shukla to felicitate Sri Gondhalekar ji, Dr. Gondhalekar ji, and Sri Agrawal ji, and Dr. Arputraj on the behalf of Dr. Saxena. Yeah, this is the memento. These are the products developed by CIRCOT. They are unique memento is there. Now we are concluding this session, and before that, just formal vote of thanks to chairman and co-chairman for chairing this session, and especially our guest speakers, Dr. Gondhalekar ji and अग्रवाल जी, आप यहाँ पे आए और सभी को संबोधित किया, इसलिए हम आपके बहुत बहुत आभारी है. धन्यवाद. और डॉक्टर अर्पुतराज जी, he is playing dual role today. He is the rapporteur of this session as well as he presented Dr. Saxena's presentation. So thank you, Arputraj ji. And with this, we are concluding this first technical session. and we are breaking for tea break. High tea is there organized in the Pendal, and immediately at 11:15 we will start with our main function of inauguration of this 99th Foundation Day. So all of you are requested to join for high tea and immediately assemble over here exactly at 11:15. Thank you very much.